All right, so this is Unit 1, Section 1.3. We're going to look at Experimental Designs Day 1. So this is going to take us away from samples and surveys and move into designing studies that are called experiments or observational studies. So we'll look at some vocab today, as well as looking at some key parts to an experiment. So our goal is to identify the type of the study and identify appropriate generalizations and determinations based on the observational studies, as well as components, and we're going to start into the elements of the well-designed experiment and compare. This one kind of goes with both of these days, so that's why we're going to spend several days here on experimental design. All right, so for day 1, looking at two different types of studies, an observational study and an experimental study. So an observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. Whereas in an experimental study, this is a study that deliberately imposes some treatments on individuals to measure their responses. So an observational study might be something where I could see your previous class that you took before AP Stats. So I could look and see, okay, are you coming from Algebra 2, Algebra 2 Honors, Algebra 3, College Algebra Trig, Calculus, and I could see, okay, does that, your previous math consumption, does that actually influence your ability to do AP Stats? And likely it does not, actually, based on my observational study. It is not an experimental study because I didn't deliberately tell you how to get to AP Stats. So I never imposed a treatment on you. That's an observational study. I do observational studies all the time. Have they been doing their homework? Have they been taking notes, or are they on their phone? Are they keeping up when they're absent? All those little observations helps me see and measure variables of interest as far as how well you're doing, what's going on in the class, any big differences that I need to look at. But I'm not attempting to influence your response, which is how well you do on the test. I want to see your best effort and see if it influences. But I'm not going to tell somebody like, oh, you stay on your phone during this hour, because I'm trying to see if homework or if your test scores improve or go down based on phone usage. It doesn't make sense to do that as a teacher. An experimental study deliberately imposes those treatments. So they really might have somebody say, okay, in this class, there's no rules as far as how much you want to be on your computer or on your phone or talking with your friends, or you can take notes or not take notes. Homework is optional. All those different things that they could try to impose as a treatment to then measure your response. And if they assign you certain things, that's an experiment. So parts of an experiment, we're going to have our explanatory variable, and this is the independent variable that explains the outcome. And this is the dependent variable, which responds as the response variable. This is response, so this is the outcome. Okay, so these two variables are kind of what we're designing our whole observational study. I think doing your homework explains your test scores. Okay, that could be an observational study because I'm not going to assign some people do their homework and some people don't. I'm not going to make those two treatments. I could, in an experimental study, actually assign that says homework's optional here, mandatory here. We have to be careful of this third variable that's called the lurking variable. This is a variable besides the explanatory variable that may influence the response variable. So a lurking variable could be not the fact that I assigned you homework to improve your test scores, but this just could be you've already done this type of study before. You're already interested in this, so it wasn't your homework that improved your test. Maybe it was your ability. You can just listen and you do well on tests. You don't have to do the homework. Maybe it is prior knowledge, okay? So maybe you have prior knowledge that allows you to, again, not say it's the homework, but you still do well on the test. So those are the things where we want to account for as many lurking variables as we possibly can. And what happens if we don't control that is this last piece here, which is confounding. Confounding occurs when two variables are associated in a way that their effects on the response variable cannot be told apart. So if we did have homework that was acting and we had prior knowledge acting, how do I know if it's the homework that improved the test or was it your prior knowledge? Confounding is when I would say the homework and the prior knowledge are confounded here because I don't know which one is improving that test score. I need to do more control on my experiment or more ways of kind of controlling the prior knowledge. If I want to assess for that, I need to make sure that my groups are equally represented there. Something that I can say in the end, these are not confounded. Because when you do an experiment and you make big results, some things that can happen is that you want to make sure that nobody else can poke holes in that design. So you don't want to say, well, it's not homework because they've already taken this class. Or it's not their homework that's helping them, it's that they have an older brother that saved all the tests or something. Not that anybody would do that, right? But we don't want any confounding variables here. We want our explanatory variable to act on the response, and that is the only relationship we want. We have to control for lurking variables so that they're not confounding. All right, so here's our first example. It says, does reducing the screen brightness increase battery life in laptop computers? I see my students do this all the time as an observational study. Okay, it says to find out, researchers obtained 30 new laptops of the same brand. They chose 15 of the computers at random and adjusted their screens to the brightest setting. The other 15 laptop screens were left at the default setting, which is moderate brightness. Researchers then measured how long each machine's battery lasted. Was this an observational study or an experiment? Okay, so when I first started out, I said I do this all the time, mostly because I don't tell students to, dim their settings on their computers, but I see lots of you do that because it saves your battery. Okay, in this case, they've actually assigned the brightness. They chose 15 and assigned them to have the brightest setting. The other 15 were left at the default. Because they're choosing it, this is an experiment. They're imposing the brightness as the explanatory variable, and the response that it's acting is the battery, how long it lasts, so the battery length. And so we want to kind of consider that when we're looking at our explanatory to the response. Here, right now, we don't have anything else acting on it. If they've controlled everything else and just let it go, then we can probably say there's a relationship here, a correlation, a causation. When we do an observational study, we can say that they're related, but I'm just observing this. I don't know how long people are spending on their computers and what they're doing. Are they watching Twitch? Are they watching YouTube, Netflix? What are they doing that could also be affecting battery length? So if I did not control this in an experiment, and like I do it daily would be an observational study, maybe it's not brightness that is the only thing acting on the battery length. I could have a lurking variable here of what apps you're using could be acting on your battery length. Your time on could be acting on the battery length. I need to control these in an experiment, and I need to consider them in an observational study. All right, in our next example, it says, does eating dinner with their families help improve students' academic performance? According to an NBC News article, it says teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample conducted by researchers at Columbia University. Was this an observational study or an experimental study? Okay, so if we look at this, we're having teenagers eat with their families 5 times a week. Okay, so here's one thing, and the result is better grades in school. Okay, so they didn't control this. They didn't make families eat 5 times a week. So this is going to be an observational study. And to justify my answer, we would say did not impose a treatment. And in this case, our treatment is eating with family. So they didn't impose this treatment, they just observed it happening. They said, wow, we have better grades in school. I wonder what is causing that or is correlated to that. So they did an observational study looking back with a survey to likely see, well, is this one of the things that is associated with getting better grades in school? The second question asks us, what is the explanatory and what is the response variable? So the explanatory variable is eating with family, at least 5 times a week. Okay, and when I was younger in elementary school, this was a thing. We did this all the time. I have 2 sisters and my parents, we would all eat together, and it was like very important to my family. As we got older though, and we got more involved in things, my older sister was a senior when I was a freshman, and we were just involved in so many other things and with jobs and activities. And now my mom works in Lawrence. Like all these things were happening where we weren't able to. So I'm not sure if I can say that affected my grades for good or worse, but I maintained about the same grades throughout all school. I'm not sure if I would fall into a certain category here. Their goal here was they were hoping that eating with family at least 5 times a week resulted in better grades. And I guess they can't say they're going to be better. They're just saying the response is the grades in school. Whether they're better is the result of the study. So we'd have to look and see what their actual grades were. So when we look at this type of study, this study cannot clearly establish a cause and effect. We can't say that this causes this. Why is that? What would be a lurking variable that may be confounded with whether or not families eat together? So first off, the only thing that can establish cause and effect is an experiment. So since this is not an experiment, it can't be cause and effect. So that's one reason it can't be cause and effect. We didn't have control over the students eating with their family at least 5 times a week, so we can't say that's what caused their grades in school. Another lurking variable that might be acting on good grades could be their activities. I know that when I played volleyball, basketball, and soccer, I had to maintain a certain level of my grades in order to play, and I know other students do that, so you have better grades not because of eating with your families, but actually maybe the activities that keep you from your families. It could have been like just a student drive in themselves. So they've set a goal, and so even though they don't eat with their family, or maybe they do, but we can't say it's what happened because that student's just driven in school and they want to do really well. It could be ability, that they have a natural ability to get good grades in school, and again, eating with their family had nothing to do with it. So it just said name us one suggested or one lurking variable, but here's a few that could have been. Okay, so our practice today is going to look at explanatory and response variables along with lurking or confounded variables. And then we're also going to be identifying the difference between observational and experimental studies. Let me know if you have any questions, and I hope you have a good day.